It is my pleasure to introduce Professor Hamid Haddadi as today's keynote speaker. Hamid is a professor of human-centered systems at the Department of Computing at Imperial College London. He also serves as a Security Science Fellow of the Institute of Security Science and Technology. He has won a number of awards, distinctions, and fellowships for his work, but I think one thing that is truly unique about his experience is that in addition to being an academic, he is also the chief scientist at Brave Software, where he has been spearheading their efforts to develop privacy-preserving analytics protocols. He enjoys designing and building systems that enable better use of our digital footprint while respecting users' privacy. And if you look at his body of work, he has worked on an impressive range of projects along this direction. From what I remember when I was a grad student, he did some pioneering work looking at privacy issues in online advertising ecosystem and web tracking, and how we can design privacy-preserving advertising systems. He has also built systems to give users more control of their personal data in a series of papers and projects as part of the Data Box project. He also has built systems to improve personal data transparency and control in IoT devices. He has published a number of papers and built systems geared towards IoT. And then more recently, he has done a series of works developing privacy-preserving analytics, including privacy-preserving machine learning models. And today he's going to share with us his perspective about building user-centric, privacy-enhancing technologies. So please join me in giving a warm round of applause to welcome Professor Hamid Haddadi.
Thanks very much. Thank you, Zubair. Good morning. Glad to see so many familiar faces here in the audience. Thanks very much for that introduction. So today I'm going to generally talk about a little bit about my experience, not only building stuff myself or obviously as part of the research groups that I've been on, but on the broader trends that we have seen in the space of pets. And I'm hoping that the good news is that I will not be talking for the hour. I'm hoping that this will kind of spark some conversations about some of the works that also some of the members of the audience here are working on. And the key thing that I want you to remember is that a lot of, as in the reason that we are here, the reason that we are sitting here, the reason that this community and this conference exists, if you think historically behind its creation, is actually the users, right? Privacy-enhancing technologies for whom? For the users, right? So keep the kind of the end user in mind as I go towards this. Cool. So my own research, I always had kind of a slide like this when I was giving whatever faculty interview jobs and job talks and all of that. I try to build kind of accurate and good analytics systems without jeopardizing the individual's privacy and trying to put a human kind of in the loop. So with ambient and personal data, my focus for many years was personal data and alongside that web advertising. But I kind of want to do a quick fact check about what I've done myself and what some of my colleagues have been doing. So part one, this is a briefer part just talking about ambient and IoT data, because I spent many years looking into these devices, these systems, and in many ways, these devices are built maybe primarily to help us achieve some goals. Monitor that baby, monitor that cat flap, get that TV, whatever, going and all of that. But the thing is that there's a completely opposite ecosystem around it, that the smart TV is really watching you. You're not watching the TV in a way. And the doorbells are the same. We've known that there's a very strong and well advertised and not even hidden interaction between doorbell manufacturers and, for example, police departments. And smart speakers are the same. There is a reason that these devices are also cheap, because they're kind of keen to hear what's going on around you. And we did a lot of work on this space. We discovered vulnerabilities. We got whatever free TV because we discovered the vulnerability in a smart TV, and that TV is in my lab. I tried to give it to my mom, but she didn't want it. During COVID, I tried, we couldn't access our testbed, and I tried to turn my mom's apartment to a testbed, and she smartly refused that. That was very irresponsible of me, but there we go. And there are many, I'm talking about thousands of human labelers working out there to label the data that comes from these devices. And this is kind of partly problematic for what I talk about later. So we kind of built two labs. About 6 years ago, we started putting hundreds of these devices together, and we looked at devices across countries, and you can imagine how this goes. You put a router, and you kind of try to intercept the traffic. You do person in the middle attack and machine in the middle attack and all of that for the apps of the devices and the devices themselves. And you get the traffic, and you look at that for devices, for different experiments. And we found out what, this diagram has been part of many, documentaries and news things as well. This is like 5-6 years old now, from IMC 2019. We found out that, as you can imagine, the data from these devices is all over the place. So that's a problem, because these devices are rapidly entering. If you look at Christmas sales of, for example, Amazon, IoT devices are always at the top. A lot of people give these devices as gifts to each other for a variety of reasons. And they're being used for good reasons. So like many healthcare developers are interested in enabling for example, monitoring or helping patients with dementia, early stage dementia, for example, living independently, and things like that. These are good, and these are useful goals and objectives. But it also kind of depends how we get there. So we started working on this system to block. I had worked for many years on ad blocking and traffic blocking and personal data. So we started building this system to block traffic and to block IoT kind of anomalies on the device. So we started putting more machine learning on devices, and this was in Pets and Oakland and all of that. And this was working by putting more and more intelligence on the home gateway, on the router. And we had block lists, we had device identification, all of that. And in the IoT session yesterday, a lot of similar research was presented, which is great to see. But as we started squeezing more machine learning and more intelligence into the routers, initially we started getting Competition Markets Authority, EU folks coming after us asking for stuff, and then we kind of thought, oh, this is cool, why don't we make a startup from it? And then the first customers that we had, as you can imagine, were governments and cops. How do we use vulnerabilities for monitoring? How do we use this? How do we do that? What kind of things have you not so that kind of made us think that, okay, is this the direction that we want to be kind of working on? And we kind of scrapped that startup and that company altogether, because we were not comfortable with the way that things were forming, that our first customers, the whole point of the thing was to provide privacy to the users. And the very first paying customers were surveillance kind of mechanism. And I'm not talking about whatever you want to call it, authoritarian regimes and all of that. I'm talking about governments around us. So that's kind of part one of the story. And part two, I will briefly go through the kind of the mobile and the web data ecosystem and what's been happening there. Obviously, that is far more pervasive around us than the IoT stuff. So for the last decade or so, companies have been slowly interested in doing more kind of telemetry. And how do we do this? We design a system that gets a bunch of data, and then we apply some sort of pets to it, right? Some sort of privacy tool. For example, one of the earliest ones that it was about a decade old now is what Apple started doing with emoji counting. That, okay, it was obviously difficult or expensive to do anything too expensive, so they said, okay, we are going to do this count min sketch. We will look at the range of emojis. Are very unique because if I show you a couple of emojis to you, as in if I have a look at, for example, your WhatsApp or your iMessages or whatever, and I show you a couple of emojis, you can guess whose message I'm referring to. They're very easily, you're very easily fingerprintable, because also people use tones and all of that, and they use usually just the recent list and all of that. So as you can imagine, it's a very kind of unique data set. So initially, Apple was doing this count min sketch to count what sort of emojis people use and all of that. And more or less around the same time came the idea of federated learning, that, okay, we are going to do analytics locally on the device, see what's going on, every night upload this to Google servers, and this was quite interesting for both these giants. And then slowly we started seeing attacks on it. First, some folks from Imperial, it was just random that they were from Imperial, nothing to do with me. They discovered vulnerabilities in Apple's count min sketch and what privacy gaps it has. So that kind of forced them to change that design. And then we started seeing endless papers. This was one of the very first ones from Cornell, from Cornell Tech, but we started seeing so many papers on backdooring federated learning systems. So companies had to start thinking about, okay, how do we do kind of telemetry without too much, mostly without too much PR backlash, as opposed to without too much privacy issues. Meanwhile, browsers started thinking about, okay, how do we do telemetry in the browser? So this Rapport was one of the very first browser telemetry systems, one of the very first private telemetry. Obviously, before that, the system was very simple. Life was very simple 10 years ago. You would just collect all the data and you would look at it. It was glorious time. You didn't need to worry about, now I need to worry about, oh, crash reports are very private. Of course, crash report has everything that you can imagine is dumped into one report and sent to our server. So Google came out with Rapport. The idea was to do a bit of local differential privacy through randomized response, and so you would get a bunch of features, hash them into some sort of Bloom filter through randomized response, and you would submit that onwards. And they found out that Rapport has actually quite good privacy features. Meanwhile, Mozilla folks came up with Prio. The idea with Prio was not to do so much work on locally on the browser itself, because that might jeopardize the quality of the data. So the idea was that you get the telemetry report, you look at the data, you kind of send it through various chunks through like whatever, 2 servers of oddly the same kind of entity. And the key was that you kind of, you turn, so Rapport was, I'm going to see if this works. Actually, no, I'm not going to risk it. I don't know if I press this button, all hell will break loose. So Rapport was doing kind of local differential privacy. And there was 2 other telemetry systems which weren't in browsers really, trying to do similar sort of anonymizing proxy and through Tor and all of that. And this is actually another random thing, that whenever you want to design a telemetry system for a browser, not just us, anybody says, oh, that's great, I will do some local thing, I will do some whatever aggregation and stuff, and I will just send it through Tor, and that looks private. Number one, Tor is not designed to be your free telemetry kind of carrying thing. The system is not designed for that, and it's also a bit weird for a multi-billion dollar whatever company, multi-trillion-dollar company to rely on kind of a non-profit system to do their job. And yeah, that's actually not number one. That's the main thing. And Prio was doing this secret sharing thing. And the problem was that again, so Prio had this problem that because it wasn't doing anything locally, it relied on servers not colluding. And obviously, if you have two servers from the same company breaking the traffic into two, the non-colluding part, I'm not saying that they were colluding, I'm just saying that this assumption or this threat model starts slowly kind of breaking and becoming loose. And the ironic thing is that using, for example, we talk a lot about use of trusted execution environments. That, oh, how about we put an SGX server and people can attest against it and all of that. This doesn't necessarily solve the problem again, because if it's your own server and all of that, first of all, how do I know that you're actually sending the traffic to that server? And secondly, at the end of the day, you have a server at the back end and you can put it all together anyway. And the problem is not so much, I want to emphasize that in all of my talk, I'm not necessarily saying that these companies are pretending to provide a private service while getting the data and putting it back together. The problem is when somebody knocks on your door with a request, you have to respond to that request. So, and this doesn't necessarily mean that somebody comes with a court warrant, some government which is strong enough and you have a presence in that country. And that country could include, whatever, hundreds of millions or a billion residents. Meanwhile, other telemetry systems came together. So we had dPrio and Prio Plus at the same time. So dPrio and Prio Plus were relying on secret sharing and adding a little bit of random noise. So as you can imagine, slowly differential privacy was kind of entering the world of telemetry, and this was becoming an interesting problem. And this was great work. Unfortunately, they never got adopted. And the reason for that is, when this paper came out, the reason for that became evident. That why are these good telemetry mechanisms not getting adopted for a long time? The problem was that they were too good, as in the privacy gain from these systems was quite good, so you couldn't get the utility that you wanted. And this is where, again, this kind of, if you want to call it dichotomy, came to play that, okay, we've designed this system and it's a bit too good for privacy. What do we do about it? Because if you're at any industry, if you're at any company, there's the, whatever, privacy guy or girl or whatever championing these things, and there's the data protection officer which is looking at what the EU law says and what the US law says and what California says and what Singapore says and whatnot. And there's the marketing guys, and there's the ad guy, there's the sales guy that has to kind of balance the numbers, and there's this fight always between the two. So Chrome folks came up with this, with Proclo, which there was this ESA, encode, shuffle, analyze. The idea was that you get the data, you do some local encoding, you send it through a shuffler, which is on an SGX server, for example, again, on their own infrastructure. But the idea was that you have an SGX server, and you say, okay, I'm really shuffling this data, so I'm mixing the users, and I'm not getting the data from each user directly to Google servers, and the analyzer, which would analyze the data. And in that paper, there was a key figure, actually, showing how good Rapport's utility is. And a similar figure was also in the Rapport paper. And the discussion was that because the privacy is quite high, we cannot get the data that we are interested in. And this was kind of ironic at the time. And Proclo existed for a while, and recently it hasn't been maintained much. So kind of, actually I know what else is going on there, but it's not in the public domain, so I cannot talk about it. And it's not the company that I work with, so why should I advertise? So you could see how this kind of downward spiral is going. Meanwhile, at Brave there was a star. Initially there was this thing called P3A, And this was super simple. You put a bunch of questions in the public domain on GitHub that these are the questions that I'm asking. How many tabs have been opened in the last week? How many, how many has the Tor tab been opened or not? Actually, sorry, that question doesn't exist anymore. So if you could delete that, from the talk. But very generic questions, and these generic questions would go through an aggregation thing, and they would just get to Brave servers, and then somebody said, "Oh, this is not good enough because we cannot know about, for example, crashes and all of that. So can we have a system that we can know about that?" And then came Star, so this was in CCS 2 years ago, and the idea was that you do secret sharing, and actually I have a diagram on this coming up. So you kind of get the data locally, you do secret share, you share some of the data through secret sharing. There was an anonymizing proxy with OPRF, and you would use, and in this case we were using Oblivious HTTP, but you could use Tor or whatever. We actually did talk to Tor people, and like everybody else does. And they were not against us using them, but it just feels weird that every single browser now has to enable the Tor. We have a Tor tab in Brave, and every single browser has to now run the Tor daemon in order to kind of send us telemetry. It's just not what that tab and what daemon is designed for, and it's weird to ask it for that. And anyway, so the idea was that once you reach a threshold, so you do threshold aggregation, once you reach a threshold within this proxy, then the report is sent. So if there is, I don't know, less than 20 bold people in Clifton who've searched for a hair transplant, for example, you will not transmit that data. So, but if me and Owais get together and a few more of us, and we say, actually, yeah, that's a bad example, but you know where I'm going. We are not doing this for search, actually. This is for browser functionality. There's no search telemetry. There is a new version of this coming, which has got local differential privacy. I think there will be a blog post out soon. So you could see, again, where this is going. So the question is, I've been talking for, whatever, now 7 or 8 minutes, just about browser telemetries. Why do we need so many different telemetry mechanisms? Why can we, I don't know, not like data transmission or whatever, or differential, why can we not have a single telemetry mechanism? First one is that different vendors have different requirements. These are all browsers, but the ecosystem behind them, the funding mechanisms, the income streams, the ideologies of the companies are different. Somebody relies on ad, somebody relies on whatever VPN users and all of that as an income. Somebody relies on subscribers for storage and for photo sharing on that one. So these different browsers, they have different data streams, and because of that, they have to optimize around that. But the key thing is this, is that over time, as you, initially when you design a telemetry, you're thinking really about privacy. You're like, okay, this is after the golden days that pets didn't exist, and those days were the best. You would just collect the data and great times. After that, you say, okay, no, I'm gonna. So the companies started getting more greedy and greedy. Okay, how many tabs are open? No. Ooh, how many tabs are open which relate to sport and politics? Ooh, how many tabs are open which relate to sport and politics, and the user is within this age range, and kind of this starts piling up all over each other. And the question that every time there's been a standardization effort in this space, there's also been lots of resistance through it, because simply the bigger forces that play a role in the standardization discussions, they reject and they refuse to engage in this practice simply because it might, number one, reveal the incentives that they have behind the telemetry mechanism, and number two, it might actually, anything, this is the other funny thing, anything that easily enables a user to switch from browser A to browser B, it's a bad idea. So you want to introduce friction against mobility. So there has been, as you've, I don't know if you've recently experienced, for example, installing Windows, for example, in EU. When it comes up, you get a browser choice, a randomized screen that you get like 10 or 11 whatever browsers, and you choose through that, and it gets randomized between the browsers that have over a certain number of users. This was through the EU's DMA, so the folks in the US wouldn't have seen this, the folks in EU would have seen this screen. And this led to a huge increase in adoption of, for example, more private browsers, and I'm not just talking about Brave, other things as well, DuckDuckGo, Mozilla, whatever, both in mobile and on desktop, just through the force of regulation. So if you're working in the privacy space and if you're interested in pushing pets, it's not just about building tech. Actually, Natalia mentioned this in her talk yesterday. You must engage with regulators. It's a painful process because they don't understand our language and we don't understand their language. They have different time scales for things and they have different processes, and it takes a lot of time. There is no week going by that I don't have to respond to a regulator in a country. And I'm actually not the guy that deals with this. There's an actual data protection officer. We just provide technical feedback to that. So you can imagine that, and bigger companies, they have tens or hundreds of people dealing with far more complicated requests, including government requests. We don't have that problem because we don't get any data, but the bigger you are, the more engagement you must have. So many of the young people, and actually I'm really pleased to see that this year there's so many young people here. Many of you will be working in different companies and you will have to engage with regulators, with governments, and it's really important to, I think it's far more important for the tech developers today to understand how to engage with these people. This doesn't stop here. There's other device analytics which are becoming problematic. You've all heard about when initially this CSAM thing, for example, came through. The idea was that, yeah, we are going to do on-device lookup and we will kind of detect for inappropriate material and report this to authority. And the way that this was working is that there was a private set intersection that you get a bunch of stuff. You look if the hash of that image is close enough to what you imagined, and you upload that to the authority. And this was running kind of again through a thresholding mechanism through the device. And very rapidly, it was discovered that, okay, actually this was driven partly, in a huge part by folks. Unfortunately, Ross Anderson is not among us anymore, but by folks who are in this community. And this was discussed that, look, this is simply a surveillance mechanism to be made, because once this thing is out, you cannot really stop its abusing, even though there were technical claims that you can look at the hashes and all of that, but quickly, actually, technical people also demonstrated, this was in Oakland last year, that you really cannot actually check accurately that if image A that was requested by this government was really what you thought it is, or the hash can be mapped to other people's faces and all of that as well. So it was basically showing how CSAM can be used for facial recognition. So that kind of led to bunch of other papers that they were showing all the problems that this initially well-designed. So I think the paper from Dan Bonnet and others in Apple, it was very well thought and well designed, but there were lots of corners that was kind of missed. And this is obviously the nice thing about having to put this thing. And I wish before rolling this out, Apple would have engaged a little bit more with the community. It's not the practice that they usually have, but anyway. So a lot of issues were found with that space. Only this week, we've had two new kind of announcements about private ad attribution. That so these are being turned on in, for example, Firefox and Safari. That how do we chase ad attribution, for example, in private mode or privately? These are two different things. One of them is that how do we do privacy preserving? How do I know that that person X actually clicked on an ad and it converged? So the main thing about ads is obviously not, there was a time that you were doing with this CPM, cost per mil, how many thousand ads are shown. Then you were doing CPC, how many clicks were made. And now you're looking at really conversion, that how do I chase the whole thing through? So there's a bunch of mechanisms. Privacy Pass was an initial effort at this, and Privacy Pass is now a standard, like an IETF standard. But there's other mechanisms which are coming for, even, for example, this was in Apple's announcement yesterday, that the idea is that an advertiser would be able to check how their campaign is doing, even in private browsing mode. And this is designed relatively well, but the moment that you start offering Tor, Tab, Incognito, people remember Google Incognito mode, right? The Chrome Incognito mode, and a couple of months ago it was found out that basically there was really nothing incognito about it. And there was like full tracking and all of that. And people get affected by this, right? It might not be us, but people in different countries, for a variety of reasons, they get affected by this. And it's also, this data gets fed easily, not just for surveillance, for various campaigns. I'm sure you will start receiving ads about the next US election soon, but we've had the same about whatever Brexit and UK elections and all of that. And this list goes on and on. Contact tracing, AirTags. We had the perfect example of this in the UK when contact tracing came in. There was a couple of good talks about contact tracing yesterday. So the story was that initially NHS said, oh, no, we are not doing this Apple and Google thing because we want to roll out our own app because we have a central database. And then they decided to abandon after 6 months because simply Apple was not allowing them to do background scanning. So after this was April to June. After a few months, they said, okay, and this is 3 months in the middle of the pandemic. So this was really having high impact. After 3 months, that everybody else had a different design. This design was dropped, and then the updates that eventually they had using the Apple and Google, that got blocked by Apple and Google for breaking kind of the rules that they had about data transmission and all of that. And this saga went on for like a year or so. And simply the users completely, as in the UK audience, completely lost trust in the design of this ecosystem. So the question really that comes into mind is, who are we building these things for? Are we building pets for industry? Are we building pets for the governments? Are we building pets for the user? I actually kind of have started having some sort of mid-career crisis about these things as well. And I actually thought, let me ask somebody who's been shouting a lot about this, which is Matt Green from Johns Hopkins. And I thought, let me ask his opinion on this, and let's see what he has to say. It's very short, I promise.
Hi, Matt. Thanks very much for making time for this chat. I just had one question from you. You've been thinking a lot about the space of privacy and privacy-enhancing technologies. And over the last 2 decades, we've been building a lot of privacy-enhancing technologies, telemetry, and different privacy protocols. But sometimes I feel like we are mostly making these, I don't know, maybe for the industry or for governments or for data collection at scale in a way, rather than helping the individuals as individual users. What do you think about this? And do you think there's a solution and something that we should be thinking about here?
So I became interested in privacy and cryptography because of the kind of cypherpunk dream where, we were going to take all of the things that computers were doing and computer networks were sort of eliminating all of our privacy. And we were going to go backwards to the world where, now we could just be by ourselves and lose all of that kind of invasive tech. And what's actually happened is something totally different, right? Like the world has changed. Silicon Valley and the tech world is not really interested in getting rid of that, invasiveness. What they're interested in is data collection. And what makes me a little worried about it and a little sad is that the data collection is unlikely to stop, and privacy preserving protocols seem to have been more co-opted, not so much to prevent that data collection, but to make that data collection possible and make it possible in a way that maybe doesn't reveal everything immediately about your particular data set, but ultimately kind of has the same impact in the sense that if we can collect enough data to learn about people who are like you, then we don't need to learn about you. We don't need to learn what you're clicking on. We just need to learn what people who are exactly like you, and there's a large statistical class of people who are probably very similar to you. Once we have the ability to train on people like you, then we have everything we need. And by we, I'm not referring to you and me. I'm referring to the people in Silicon Valley who are kind of driving this. And I don't know what to do about that. I mean, yeah, maybe it requires a different focus by researchers. Maybe it's inevitable, and that's just the world we live in today. But I do think that every privacy researcher should think about that and make a decision, a conscious decision about what it is they're trying to do here. Are we solving enjoyable mathematical problems? Are we trying to make the world better? Is this how we make the world better? I don't know what the answers are. I just don't think that very many people are asking those questions.
Thanks a lot. That's very useful, and I hope this will inspire the next generation of research.
Enough on me. Right, so Matt didn't also have the answer. I didn't have the answer. Matt didn't have the answer. I thought I'll just drop in a couple of potential solutions that I thought might be relevant here, but I'm not selling any of them, and they're not necessarily my works. I'm just mentioning a few. So we kind of finishing rapidly on the high note and leaving a good 15 minutes either for discussions or for coffee, whatever. Maybe local models and small models are the way to go. We've seen a lot of hype and a lot of effort on LLMs actually, but there's a lot happening on small models. And in the next few years, we are going to see hundreds and hundreds of models entering our lives. On our phones already, there's over 100 models on a generic phone, but the number is going up quite a lot. On IoT devices, so maybe small models that can learn from large models and they can do majority of the stuff locally. Maybe that's the way. Maybe confidential computing and ARMS CCA, so future that we can do really trusted execution environment works on the device. At the moment, we don't really have much of that. We have Face ID from Apple and Touch ID, and then the whole Knox from Samsung. Is this working? Yeah, I'll just stay here. We don't have many choices at the moment for running trusted things on device. So maybe that will be the way. Maybe fully homomorphic encryption, maybe secure multi-party computation, maybe zero knowledge proofs, maybe private information retrieval, and all of that. The thing is that we need to start thinking that how do we build these pets that really are useful for the user. And there is a couple of good examples to really finish on a high note. We've seen whatever, obviously, Tor is a pride of this community, Signal and Snowflake and all of that. So things are getting better, but we need to take charge. We need to think about these complex challenges that we have between data collection, telemetry, government surveillance, advertising, marketing, and each of these have got different requirements, right? Marketing and surveillance and advertising and all of these things, they have different levels of granularity. And this is partly the challenge of designing. I was speaking to one of the colleagues here about a different telemetry design, again, for a different system. And every single system is unique. So the problem is that there's no one-size-fits-all solution. But as majority young and active researchers here, I think it's going to be onto you to think about how do we design systems which actually enables the users. I mean, we see all these ads about what happens on your device stays on your device and all this BS, but yeah. Maybe trusted local analytics are the way to go, but these are just some of the suggestions that I have, and I'm happy to hear about any opinions and any thoughts that any of you might have. And I finish on that note, and thank you very much. Thank you. Thank you. I don't know where the mic is. Maybe you can shout and I can repeat if you want.
That's a loud voice, I can try.
No, you can shout slowly and I repeat your question.
Okay, I mean, there's people also online, so I guess.
Oh, yeah, that's right. Yeah.
Involve them in some way.
I think if the mic doesn't come to you, you go to mic.
Well, thank you very much for the very insightful talk. I guess I have a sort of comment and a question. You left it on this thing of like, even Matthew Green does not know the answer of like what we should do, which objectively is a little bit depressing. You know, I think we need to recognize that. But also, I was wondering if you had some thoughts on like how much of a role standards, let's say, let's take ITF or like other standardizing bodies, which we know are very heavily driven by industry. And even more so, I would say, you know, there was this talk about the cypherpunk dream, right? If we look at older RFCs, we see much less industry involvement, right? It was like people that come from small companies or like individuals contributing to them. And now you look at the authors and it's all just like Google, Apple, Microsoft, you know? And so I guess the thought is like, how much do you think standardization of protocols ends up being kind of a backdoor, if you wish, to push an agenda which just reinforces the structures of power of these big tech companies? And I don't know, do you think that plays a role in being able to push for some solutions that are more in the interest of, let's say, the individual or civil society as a whole?
Yeah, you didn't actually leave much room for me to respond to that, to be honest, because this is exactly partly the problem that we are exceedingly facing in the standardization efforts. That obviously the bigger a player is, specifically a few big companies, the far larger presence they have in standardization efforts. And actually even taking part in standardization is not cheap, as in rocking up to IATF and hanging out for a week and stuff like that. For a small company, it's actually quite difficult, or for a non-profit and things like that. So I think there's a role to play actively in changing maybe the standardization landscape, that we don't get in a meeting, I don't know, and I'm not exaggerating, this is exactly what happens. You get like 30 people from a single company forcing a single point about the standard. And that makes it very difficult for companies with one or two people to kind of fight against that. So I think it's going to be a very difficult challenge. Maybe the solution is to start rethinking how standardization also works in the bigger domains, but it's not going to be an easy fight, especially because half of these young people that I'm addressing to will probably be working for a big tech in the next few years. So, but I think it's time for the new generation to start thinking deeply about this stuff before engaging in developing tech. And these companies also have great kind of ideology programs and speeches that really I've noticed the effect on some of the younger people when they join them. So it's also good to start thinking about how to immunize PhD students when they join one of these kind of companies. But I'd be happy to hear any other thoughts.
So thank you for your Can you hear me?
Yeah. No.
Yeah. Thank you for your talk. Very interesting, and thank you for being honest with this question. Actually, when I started my PhD in 2012, it was for a project that involved many universities in Switzerland, trustworthy cloud storage. And very early, I started being depressed about what's happening in the cloud and Silicon Valley. But at the same time, I was very lucky because I started reading works like, for instance, from Ross Anderson, like Eternity Service and other things. I've been involved in Freenet, in a Google Summer of Code, and all these kind of things. And this decentralized movement started to appear. And actually, I was involved from the very beginning. And I was in San Francisco and participated from this Decentralized Summit at the Internet Archive. So that really gave me hope. Unfortunately, it's not seen much in this conference. So I'm thinking like, it's all about, okay, let's just cover the roof is leaking. Let's cover the roof with the hands and trying to search about, these guys are spying us. These other guys are spying us. It's all about spying. Why not just let the guys spy? I don't care. I use my energy to build something new. I use my energy to do research in decentralized systems because there's a lot of people building this kind of stuff. And I'm surprised that we are not discussing these things in this kind of conference.
Great points. I mean, these examples that I put up, for example, all are kind of decentralized systems, and really is the way. That's the way to go. One problem that we face is that, for example, what was the biggest and most successful decentralized system that we had until very recently? It was email, right? And then look what's happened to email in the last few years and how much more centralized it suddenly has become, simply because for a generic mail server maintainer, keeping up with all the security, compliance, regulatory, government, all of these requirements has just become so hard that there's only a handful of companies that now 99% of the whatever email in the world relies on. And that's a little bit depressing, but I think we need to keep fighting this fight, and I'm glad to see, for example, folks, for example, in Signal are resisting a lot of, for example, requests, for example, the end-to-end encryption breaking scenario that Ross, amongst other, was fighting against. The thing is that if it's not the people in this community, it will not happen. So we need to keep fighting the fight and keep building good tech. I agree. There are people doing great works, for example, on decentralized VPNs and all of that. This is really the way to go. And I hope to see more of that. So the high points that I was kind of trying to end on is that it's not so bad. We can do it. We can do it. We need to keep building, but we need to keep engaging with the regulator. We need to keep fighting the fight. I'm happy. I'm ready for the next.
Harry from. Oh, maybe I'm not next.
Oh, you got intercepted. Sorry. Where are you, Harry? I can't
Okay,
see.
sorry.
Oh, yeah.
Harry, CEO of a decentralized Mixnet, but previously W3C crypto guy and liaison to IETF. So just a quick note on the standards process. So the W3C is very closed and heavily dominated by browser bodies, but I left that standards body because they standardize DRM and they're irrelevant, right? So the actual action in browser standards happens in WhatWeG, which is essentially completely open, and ditto IETF. IETF, is completely open. You can just join mailing list. I did it as a grad student, and actually I've seen DDoS attacks essentially on the standards process by angry grad students and people interested in privacy successfully change standards. So it's completely possible I would say if you work for a small company, obviously you need to be more careful with your time. But if you're a grad student or researcher looking for impact, it's pretty easy to get involved in IETF and then try to either stop bad things from happening or help good things happen for privacy. So I would recommend people do that. However, there's a trick that IETF plays, just so people know, where they basically put all the civil society people and kind of nice activists in a human rights research group, which argues about human language usage and standards, and it's completely irrelevant to the actual cryptographic and privacy properties of standards, it's important that if you join the IETF, which is just joining a mailing list, there's no other process, you actually join the technical standards work and not like a kind of discussion forum. So I would recommend people do that. But my question is otherwise, which is, I didn't really get your opinion about what Matt Green said. So what Matt Green said, just to summarize, I thought he said, well, you know, we want everyone to have the right to be left alone. Now we're constantly surveilled. And now maybe if I'm not individually surveilled, I'm just surveilled as part of a group. And do you think that being surveilled as part of a group has terrible effects on, like, for example, autonomy, democracy, politics? Do groups have right to privacy? I do feel like this is under research. I'd just like your opinion on this.
So a couple of things. Firstly, I did not directly advertise your work, but I indirectly mentioned this is great stuff, and we need to keep building this. There's so great work that you folks are doing. And yes, also I encourage 100% also privacy working group in W3C and all of that for people to engage with these things as much as possible. And finally, throughout this talk, I tried to avoid having any opinion about my own work, or as you saw, I didn't also mention much or anything about my own work. I think there's lots of great research on the impact of this sort of group surveillance on what happens on a societal level. Great examples of this were, for example, Cambridge Analytica case, right? That was exactly the approach that they took. It wasn't so much on the individual level, but there were different targeting campaigns around group types. So I think there's the problem with privacy, and this is not addressed to anybody in this room. The major problem with privacy, as you know very well, is that unless something happens to you as an individual, you're not really aware of what's going on. None of you are impacted by this sentence, but the reality out there is for the increasingly knowledgeable and increasingly educated users are still waiting for something to happen to them, and then they get a bit of an impact. But also that also means that we need to do more on the education side as well. Do take part in outreach programs, blog posts, put material out there, put teaching material out there, and let's build because this is actually very hard stuff. I mean. How many people understand these acronyms? It's very difficult tech to actually understand. I'm aware of some of these. I don't know how fully homomorphic encryption works. I don't even know how partial homomorphic encryption works. Is it easier than fully homomorphic encryption? Whatever. Anyway, sorry, that was silly. So I don't have an opinion on this, but I agree that we need to engage, as privacy researchers, we need to engage far more in the standard, because it's just again, going back to my postdoc days, for example, it's a very tough world to enter. It's a very complicated world to enter the standardization process. But in longer term, it's worth it also for the young people in the audience, because you learn much more about how the world actually evolves, which is not necessarily about building tech, putting it out there, and hoping that it gets adopted. Thanks for your comment, Harry. Sorry. Yes, I think it's now.
Thanks for the for the nice talk, and especially thanks for putting the regulator a bit in the picture. But I think I would like to extend on this a little bit and with a question. And I think, so regulators basically are following norms, and these norms are usually set by some law. And so we have a whole policy making world which puts our frame, right? And of course, in particular, if you look to Europe, we have strong norms for privacy, GDPR and so on. But the interesting is these are changing, of course. And they're not changing, like the GDPR is not changing at the moment, but they're changing because the norms around it are changing. And then we see stuff like the new NIS directive, which is kind of a bit of scary because it actually weakens the GDPR and people don't notice so much. The AI Act has sometimes similar features, and we can go on other regulations there. And my impression is sometimes that our community is sometimes a little bit too easygoing on these processes, and I would ask you what to do, how to get our community to the people who are changing these policies, right? The policy-making world somehow, and taking kind of influence on this, because I sometimes also have the impression that the policymakers, and I have been in both worlds, they are just not aware so much about sometimes of their impact. They not always well-meaning, but sometimes even well-meaning and still damaging. So my question is how to better engage with these, group, which I'm aware is cumbersome, because most of the time it's very political, and political discussions are not necessarily based on fact, but very based on feelings, and sometimes for computer scientists this is a little bit hard, at least for me. So how to engage with these people?
I'm with you. I find it far easier to sit in the lab with students and working on stuff than hanging around 3-4 hours with the dude from whatever competition markets authority who wants to know, oh, how do we enforce rotating passwords or not passwords by default in IoT devices, right? It's a long and tedious process to engage with this. And more importantly, we are not trained in part of our PhD and stuff to talk to these people. And this is partially the problem. And the university does, I mean, my university doesn't have any program of public speaking or anything. There is no training for PhD students on this. So I think this is something that maybe we need to think about how to create this sort of thing. Maybe for future PETs or sort of, maybe also invite, I don't know, somebody from CNIL, invite somebody from ICO. Let's understand how these people think and how the process works. There's a couple of people, for example, CNIL is a good one. We have, for example, Vincent Obiana, who's very engaged in the academic domain. And that's what makes CNIL one of the best regulators, because they actually engage directly with academia. So is, in a way, more or less ICO in the UK, depending on who today is our prime minister. Tomorrow it might change. As you know, we have a very dynamic leadership in this country. So I think part of this process is to bite the bullet, go to these events, talk to them, learn the process. This is better for an early stage academic or something like that rather than a PhD student, because you have also more time. I'm not saying you have more time, as in it's a bigger career building exercise to learn this early, and it's worth it in 10 years' time. Many of them now, at least in the UK and France and all of that, many of these regulators and many of these government bodies, they actually have kind of internship or secondment or placement programs for academics. The simple reason is that they are interested in also, I mean, as in governments now understand that if whatever Apple or whatever, even Signal, right? Even Signal turns around, or I don't know if you saw a couple of days ago, just 2 days ago, the argument between the Vestager, the EU kind of main DMA person, and Elon Musk. The debate that they had on Twitter about if X is whatever compatible, complying with the DMA or not. It was mind-blowing that this dude is talking to the EU person like that. So the kind of the summary is that increasingly these governments, at least in the EU, are also interested in defending their position, and they appreciate input from academics. They can't always take action of it, because obviously they're also interested in making sure that the economy and whatnot, and this is partly part of the process as well. But I look in the audience, and there's many people who already engage with regulators, so do talk to them as well.
On that note, let's thank our keynote speaker.
Thank you very much. Thank you.